In this video, we will be looking at symmetry and skewness. When we talk about symmetry and skewness, we are actually talking about the shape of a distribution. We had previously talked about how we can use histograms, stemplots, and boxplots to display a distribution. We will be using these tools to help us talk about symmetry and skewness. A distribution is said to be symmetrical if it can be divided into two equal sizes of the same shape. In contrast, this would be a histogram that is not symmetrical. This is classified as a skew distribution. Skewness refers to asymmetry. We can have distributions that are skewed to the left, and we can have distributions that are skewed to the right. We read skewness based on the direction in which the data points cluster. A distribution is said to be skewed to the left if it has a long tail that trails towards the left. In contrast, a distribution is said to be skewed to the right if it has a long tail that trails towards the right side. The same thing can be applied to a stemplot. This stemplot would be skewed to the right. A good way to determine the skew of a stemplot is by flipping it onto its side. When you view the stemplot this way, you must make sure that the position of the stems are positioned like a regular number line, where the lower number starts from the left and increases towards the right. We can see that there is a long tail that trails towards the right, so we can say that this distribution is skewed to the right. When determining skewness for boxplots, the presence of outliers may affect how we interpret the skewness. For example, for this dataset, we can construct this regular boxplot. We might think that this distribution is skewed to the left, but when we convert it to the modified boxplot, we can see that this dataset is actually skewed to the right. And so when we are trying to determine the direction of skew for boxplots, we can implement a strategy. If we have unequal boxes, the side of the box that is larger determines the skew. In this case, the left side of the box is larger than the right side, so therefore this is skewed to the left. If the boxes are equal in size, then you would have to look at the whiskers to determine the skew. The longer whisker will determine the skew, so this would be skewed to the right. If the boxes are equal in size with the same whisker length, then the distribution is said to be symmetrical. With symmetry and skewness in mind, let's see how they affect the median and the mean. When we have a symmetrical distribution, you should notice that the plane of symmetry will always be at the median because it is the middle data point. And because the mean is the balance point of a distribution, you should also find that the mean is equal to the value of the median. In this case, both the median and the mean would be equal to 12. Now, if the distribution was skewed, the median would not be at 12 anymore. Remember that the bars of a histogram always correspond to the frequency, and so we see that to the right of 12, we have more data values than there are to the left of 12. By doing some calculations, you should find that the value of the median is contained within the interval between 16 and 18. And because the mean is the balance point of a distribution, skewness will affect it, so it will be closer to the tail. So we say that if a distribution is skewed to the left, the mean is less than the median. In other words, the mean will be closer to the left side of the distribution, and the median will be closer to the right side of the distribution. In contrast, if we have a distribution that is skewed to the right, the mean is greater than the median. In other words, the mean will be closer to the right side of the distribution, and the median will be closer to the left side of the distribution.